Hi guys, Lever here from Bright Young Brains. In this video, we're going through the entire paper 2 of the 2024 November exam. The only thing is I'm actually going to go through this paper from the back to front. I'm going to start with the last question and then I'm going to work my way backwards. In this particular question, you can see that we're dealing with question 11, which is the last question in this exam. It says there in the diagram A, B, C, no, that's not correct. It says A, B, G, and F lie on the large circle. So there's A, B, G, and F. They're on the large circle. Yes, that's fine. And then it says here the smaller circle is drawn. The smaller circle here is drawn to touch the larger circle internally at A. So as you can see, as I'm reading the question, I'm also referring to the sketch so that I have a mental image of what I'm supposed to be seeing. And then it says here EA is a common tangent. So if it's a common tangent, automatically we have the 10 chord theorem specifically here. You can see this is quite a big point here because there's a 10 chord theorem happening. I will come back to that. Then it says here EBCF is a tangent to the smaller circle. That's quite interesting. So that means we have a 10 chord theorem here, this equal to that, and this angle here equal to that. So there's a lot of information in this question, quite a lot actually. And then it says here AC, where is AC? So you see what I did there? I read the statement, automatically I wanted to find out where AC was. AC is over here. And then it says here AC is produced to G. They didn't say anything about AC being a diameter to this smaller circle. And AG, we also don't see anything about them saying that it's a diameter, so we cannot assume anything. It also doesn't look like a diameter. It says here AF cuts the smaller circle at D. And then it says you have these are the lines that are drawn, A, B, C, D, GF, and so forth. Okay, so that's quite a lot to take in, but let's see what we can do with the information that they have given us, right? So the first thing that they want us to do is to determine, they said we should, what did you say? They said if EAG, so let's go to EAG. So there's EA and then G. They said if this entire angle here, EAG, if that entire angle is equal to X, determine with reasons 4 other angles that are equal to X for a whole 6 marks. That's quite a lot of marks for this particular question. So with all questions like these, right, the one thing that you'll always hear me say is that just work on them bit by bit, slowly, and then you should be done. So seeing what they're asking here, right, and looking at all the information that we're given, what should we be looking at? Well, without wasting anyone's time, let me just do the following. Let me just tear out some paper here, and then let's just do what we gotta do. So the first thing that you can spot on the sketch here is that this angle, I wish I had my tablet today, but I don't. So this angle here is equal to X, right? And the first thing we already specified was that based on our 10 chord theorem, this angle here, we have a tangent over here. And then for the big circle, even the small one, this is a tangent for the small circle and the big circle. This we can look at it as our chord. So if this is X, this also has to be X. 10 chord theorem. You see, that's the first thing we're gonna need to mention. We're gonna need to mention that EAG is equal to D1, which are both equal to X. The reason is 10 chord theorem. This is quite straightforward, nothing major. And then now that we have found one angle equal to X, right, what you can actually do for yourself is we still have the 10 chord theorem here. especially for the big circle, because this whole line here is a chord, this line is a tangent, so this whole angle is equal to the entire angle F because of the tan chord theorem also. So we're going to write that as well. EAG is equal to F, which is equal to X tan chord theorem. Today is such a strange day. I don't have my tablet and I'm using a camera from a phone that I haven't used before, so today is quite tricky, but let's just try and make it work, huh? Let's see the next thing. What can we also do? So the thing is, as you find angles that are equal to X, find angles that are equal to those angles. So for example, let's see this value here, it's quite okay. Funny enough, the moment we've figured out that this is equal to that, automatically these lines now have to be parallel. We just have to remember that, you see, because these are corresponding angles. So if they're both equal to X, it means these lines are parallel. That's information we can use later on, I guess. So they said 4 other angles, so we only found 2. So what can we do to get the others? Let's go back here, or even let's go back to our tan chord theorem, or rather we have a tangent here also. Remember, we said that this angle here is equal to that one because of the tan chord theorem. So we're going to say that C1 is equal to D1, which is equal to X. We're going to say tan chord theorem again. See, theorem. Don't mind my handwriting. I noticed the camera was not even pointing while I was writing. Yeah, we have a long way to go, but let's make this work. The next thing that we can already also see is that C1 is equal to C4. These are vertical opposites, you see. So C1 here, you can say it's equal to C4, which is equal to X. The reason is vertical opposites. There we go. So with that being said, right, I think we have the 4 angles that they are referring to. So we're good. 6 marks in the bag. And then they said here, prove that that expression is equal to that expression for 4 marks. This camera is shaking too much. They said that we should prove that this AB is equal to AC times AF. It's a 6-mark question. This question is too obvious. This is the type of a question where the way you're going to solve it is you just have to look for the triangles where those lines are. So if you look at AG is this long line here, AD is this small one here, AC is this small one here, AF is that long one there. So this is straightforward. It's just our similarity theorem that we're seeing there, because if you look at the 2 triangles, as we said, so these lines are parallel. Let's just make sure we tell them that first before we even do anything. This was question number 11.1, and then here we want to do 11.2. Okay, fine. So with 11.2, the first thing we're going to need to prove is that this small triangle here is similar to the big one over there. Okay, so we're going to say here in triangle A, we're going to say triangle AGF, right? AGF. In triangle AGF, right? And triangle ACD. In those 2 triangles, we're going to need to prove similarity. So the first thing we're going to say is that A3 is a common angle, right? A3 is equal to A3. That's just a common angle. Secondly, we know that D1 is equal to F. That's been proven. D1 is equal to F, which is equal to X. That's been proven. Lastly, these 2, we can say they are equal to each other, literally because of interior angles of a triangle. We can say C2 is equal to G. C2 is equal to G. Reason is sum of interior angles of a triangle, because remember, if you have 2 pairs of angles that are equal, the third ones they are automatically equal because of the sum of interior angles of a triangle. So Now that three angles are all equal here, we can then say therefore triangle AGF is similar to triangle ACD. The reason is angle, angle, angle. You've proven that three angles are equal. Now because you've done that, now you can just use the proportionality theorem. You can say that AG over AC, AG over AC is equal to GF over CD, GF over CD, which is equal to AF over AD, AF over AD. Clearly we're going to use, so the reason here you're going to say proportionality theorem, prop theorem. Now all this being done, you can take this ratio and this ratio together. You can have AG over AC equal to AF over AD. Here you can cross multiply this times that. AG times AD is equal to AC times AF. Now that's what they wanted us to prove there. You see, we can just do that. That's giving us 4 more marks. So in this exam out of 150, we currently have 10 marks. Not bad at all. The next question says we should prove that these two triangles are similar. It's triangle AGF and triangle ABC. Very simple to do, because all you have to do is to prove that angle A for this triangle is equal to angle A for that one. G is equal to B for this one, and then you have to prove that F is equal to C for this one. So that's straightforward. That is as straightforward gets. I don't think we're going to have any trouble with this question. So the first thing you would write out is what we almost did at the top here. You're going to specify which triangles you're working in. So we're going to say here, this is 11.3, right? So we're going to say in triangle AGF and triangle ABC. In those two triangles, so you see this angle A here, we have to prove that it's equal to this angle A over there, because where there was A for the one triangle, there's A for the other one. But you always try and use the ones that are easier to prove. So for example, if you look at where G is over here, and then B is over there. G and B are equal because they are angles in the same segment, you see, because this B2 is subtended by AF, G is also subtended by AF. So let's write that down. We're going to say B2 is equal to G. The reason is angles in the same segment, you see. So those are straightforward, easy in these two triangles here, AGF and ABC. So the next one is clearly the C and the F. These are equal because they're both equal to X. So we can say here C 1 equal to X, that's been proven. And then we can say that F equal to X, that's also been proven. Therefore C1 rather, yes, C1 is equal to F. So two angles we have proven to be equal. So the third one, which is A3 and A2, right? So we can say here therefore A2 and A3, these are equal. The reason is sum of interior angles of a triangle, you see. So we've proven that three sets of angles are all equal. So because we have done that, right, it has made our life very, very easy, because now we can just say therefore the two triangles are similar because of angle, angle, angle. There we go. So let's write that down, right? Let's just write that down with this small space that I've created for myself here. Therefore triangle AGF is similar to triangle ABC. The reason is angle, angle, angle. That's another 4 marks. So in this exam we have 14 marks so far. Not too bad at all. Okay, let's move on to the next page. I remember tearing out a page and now I haven't even used that page. Oh, that's quite interesting. But let's see. Should I use this part? Yeah, why not? Anyway, so with all this being done, right, the next question is they're asking us to prove that gf squared is equal to that whole expression over there. Okay, question number 10. It says here in the diagram r s t is drawn, and then they say the line AB intersects RS and RT at A and B respectively, such that these two lines are parallel. This is a very common question, very common proof. Reading some more, it says here, prove the theorem which states that a line drawn parallel, so a line drawn parallel to one side of a triangle. So this is the line they're talking about. This line here is drawn parallel to one side of this triangle here. They said we should prove the theorem that this line divides the other two sides proportionally, which is line RA and AS, and then line RB and BT. This is a very common proof. The way we're going to go about it is very simple and very straightforward. So the first thing I'm going to do is I'm just going to redraw the question, right? Don't mind my handwriting. But the knowledge that you'll get from that handwriting is very, very essential. So anyways, this is R, there's A here, there's S here, there's B here, there's T. This is very direct and very simple and very straightforward. All you have to do for proving that AR over AS is equal to RB over BT, what you're going to have to do is the following, right? You're going to need to make a construction. You're going to construct line SB, and then you're going to have to construct line AT. So let's do that first. Construct SB. Woo, my book is falling. Construct line SB and AT, and then you're also going to construct a line, I'll just write it here, line H perpendicular to RB. So you're going to construct line H here. Make sure it's perpendicular to RB, and then you're also going to construct line K. You're also going to make it perpendicular to AR. Okay, so these are the four constructions you have to do. Once you make these constructions, right, the following is what you're going to need to do. You're going to need to make use of the triangle up here. So this triangle ARB, right, you are going to get the area of this triangle. You're going to get the area of this triangle using this as the perpendicular height, and then using this as the base. Secondly, if you look at triangle ABT, you're also going to use H as a perpendicular height, because if I redraw ABT, it will look something like this. There's a T here, there's B here, there's A somewhere there, and then here you have line H. So what you want to recognize is that ABT and triangle ARB, they have the same perpendicular height there. One base for this triangle is one base for this triangle is AB. The one base for this triangle is BT. So the first thing you're going to say is you want to write down an area for triangle ARB. So let's just do that. Area of triangle ARB, right? You know that it is equal to a half. Your base is AB. Your perpendicular height is H. Half base times height. And then you're also going to write the area of triangle ABT. So you can put your area of triangle ABT. It's also going to be a half. And then you know that the base is BT. no, I put A by mistake. It's supposed to be R. Yeah. So the base here is BT multiplied by the perpendicular height, which is H. Now, what you will actually do is you will need to write the area of the one triangle over the area of the other triangle. So having to have done this, 1/2 cancels 1/2, 1h cancels 1h. Before you carry on, or rather to carry on, you're going to do the same thing, but you're going to still use this same triangle. However, you're going to use this as its base, and then you're going to use k as its perpendicular height. You see, k here is going to be its perpendicular height, this is going to be the base. And then you're going to use triangle ASB. AS is going to be the base, k is going to be the perpendicular height. Because if you look at the triangle ASB, right, there is A somewhere here, there's S somewhere there, there's B somewhere up there. AS is your base. You see, your perpendicular height is k, like that. But let's write out the area of this triangle here, triangle AB, or ARB. The perpendicular height is going to be k, the base is going to be RA. So let's do that. Area of triangle RAB again, RAB or ARB, whichever way you want, but I think it's best we keep things uniform. Let's still also call this ARB. So this area over the area of triangle ABS, area of triangle ABS, this is going to be equal to the area at the top, right? It's half multiplied by the base AR multiplied by the perpendicular height k. So it's a half, base is RA, perpendicular height is k. The triangle down here, same thing. The base is AS, perpendicular height is k. So the area here is a half, base is AS, perpendicular height is k. Just like what we did here, this half is going to cancel that half, this k is going to cancel that k. Now what we know is that in our expressions, all this that we have written down, right, what you need to then remember is that firstly, ARB and ARB, it's the same triangle twice. Now there's a law that says that the area of two triangles that are in between parallel lines is equal. So let's state that law. We're going to say that area of triangle ABS, oh my goodness, area of triangle ABS and triangle ABT area of this and this are equal. Okay, the reason for that, let me write here reason. The reason is areas areas of triangles in between parallel lines are equal. You see, that's a law. There's a law that says that the areas of two triangles that are in between parallel lines are equal. So the areas of this triangle here and this triangle there, they are equal because they are two triangles that are both in between the parallel lines AB and ST. So we need to be careful of that. Moving on, we are going to write the following. So since these two areas are equal, right, it means that the area down here is equal to the area down there as well. So as a conclusion, you can then say therefore area, or these two are equal, right? These two, they're equal, you see. So because these are equal because you see the top is identical and we have shown that the bottom is also equal. So you can then say therefore RB over BT is equal to RA over AS. You see, that's gonna give you your 6 marks over there. This is one of those proofs that are a bit annoying to write out. It's a lot of writing, but this is all you have to do. It's quite straightforward. You can replay back this video, see what it is that we wrote down and why we wrote it down. Anyways, let's move on to 10.2. 10.2 says the following. It says in the diagram, O is the center of the circle. So yeah, that's very important. It means that if this is O, that's the center of the circle. It means this is a diameter. Automatically means that S is a 90-degree angle. And then it says here PWS. PWS is drawn, so that's a right angle triangle automatically. PW and S are on the circle, yes. Then it says here OR is perpendicular to PS. That's something they'd given us. So because we know this is 90, automatically we need to make sure that we remember that these lines are parallel, because these are both equal to 90. Then it says here PRS is produced to T, SW and OT intersect at V. Then it says here OV. The ratio of OV and OT is 1 to 4. That's very important. Anyways, so they say it here, prove with reasons that the ratio of OR and WS is 1 to 2. Okay, very interesting, very interesting. What you need to also remember is that these lines here are equal because they are both the radius of a circle. And what else do we know? Well, it's a 5-mark question, so we don't want to take this 5-mark question lightly at all. Otherwise, we will lose marks unnecessarily. So let's approach this question with the respect it deserves, I guess, because yeah, it's an interesting question. So the way you're going to prove this is you're going to need to keep in mind that the only ratio that we're given here is the ratio 1 to 4. So if the ratio here is 1 to 4, it means that the ratio between the big, if you look at this big triangle ROT and the triangle SVT, logically speaking, the from O to T we can think of that as 5 parts, you see, and then from V to T that's just 4 parts, which is okay. But then our main focus here, or the question rather, is asking about OR and WS. Well, that shouldn't be too bad. Let's firstly look at how these are equal. We can basically use the midpoint theorem to prove what they're asking here. It's very simple. We're not even going to use this 1 and 4. This is what we're going to do. We're going to firstly need to state that OP is equal to OW because they are radii. Okay, so let's just do that first, right? This is 10.2.1. We're going to state that what? We said that OP is equal to OW, they are radii, right? And then because they are equal, let's also state that these two are parallel. So let's state that this is equal to 90 first. PSW is equal to 90. The reason is angle in semi-circle. So we are doing that so that we can say that these are parallel, right? So we can say here therefore, or rather let's just state that PRO is 90, given. PRO is equal to 90 degrees, that's a given, you see. So all this information is leading us to then being able to say that therefore OR is parallel to WS. Okay, the reason is corresponding angles are equal, and then you can state which those two angles are. We can say here PRS and PSW, corresponding angles are equal, therefore OR has to be parallel to WS. So all this is so that we have parallel lines and lines that are equal here. So as long as you have parallel lines, as long as you have a structure like this where you have one side of a triangle that is parallel to the line inside a triangle, if it is parallel to the third side and it also cuts one of the sides in half, it means that this line is half that one. That's like a law. It's a midpoint theorem law. The law says that if a line inside a triangle is parallel to one side of that triangle and it cuts one of the sides of that triangle in half, it means that this side will be half that one. It's a law. So we're gonna simply just reiterate that law, right? We're simply going to say in this situation we have POW, so there's PO and W, and then there's PRS, so there's PR and S. So here we're simply going to put the following. We're going to write down that OR, we're going to say since OR is parallel to WS and OR bisects PW in half, it means that OR is half the length of WS. The reason for that is midpoint theorem. You see, therefore you can write here, therefore you can write out the ratio. Therefore OR to WS is equal to 1 to 2. That is how many marks that we're getting? We're getting 5 good marks. 5 good marks. And let's just keep moving. You see, 10.2.2 says for 5 marks, calculate the length of PT. Where is PT? PT is this whole length there. Calculate that length if ST is 15. Okay, it's an interesting question, but it's fine. If you're going to calculate PT, right, and this is given as 15, obviously you're going to need to make use of this ratio here, 1 to 4. Because these are equal, automatically it means that these have to be equal because of the midpoint theorem. So let's just state that first. You see, for 10.2.2, the first thing we're going to state is that PR is equal to RS, midpoint theorem. PR is equal to RS. The reason is midpoint theorem. Okay, so with that being said, right, obviously you know that as long as you can find the length of RS, you'll have the full length there because you can just double it. So this 1 to 4, we're going to use it to get this length here. So in this image, ORT and VST, we're going to say the following. We're going to say that OV over VT, OV over VT is equal to RS over ST, RS over ST. The reason is proportionality theorem, right? So we can say here, therefore 1 over 4, which is the OV and the VT. You see the OV and the VT, that's just the ratio of 1 over 4, they gave it to us. And then on the other side here, ST is a 15, so we can put a 15 here and then have RS open. Working out RS, we can just cross multiply. This is going to give us 4RS and then 15. Divide both sides by 4. RS is, we can just leave it as 15 over 4 because that's going to be a fraction. Now since we have RS, right, we know that therefore PR is also 15 over 4 because they are equal. We've already proven it up there, you see. So now we know that this here is 15 over 4, another 15 over 4, and then we have a 15 over there. So automatically by default it means that therefore PT is equal to the 15 over 4 plus the other 15 over 4 plus the 15 over there. You see, this here, if you add it up, what is this going to give you? 30 over 4 plus 15 over 1. 30 divided by 4, that is maths is not mathing. This is 4 does not go into third without leaving a remainder. But we can just, I was about to say I don't have my calculator here, which I don't, but that doesn't change anything. 30, this is going to be 60 over 4, 30 over 4. This is going to give us 90 over 4 as our answer. So you can put that length as 90 over 4, but if you want to simplify it, you can end up with 45 over 2, and then if you want to simplify that further, the best you can possibly do is that 2 goes into 44 22 times, and then there will be a half left. There's your answer, 22.5. There you go. Moving on. So that's about 15 marks that you're going to get here. And before this question, there's question number 9. So let's go to question number 9 since we're working backwards in this exam. Question number 9 in this November 2024 paper 1 exam. Oh no, paper 2. Oops, it's a paper 2 exam in 2024. It says here, provide reasons for the statements in question 9, 10, 11. Working backwards. So anyways, in the diagram, A, B, C, D is a cyclic quad. So it means that this exterior angle is equal to that one. That's just a law. So many things we know about exterior angles of a shape. Then it says a BC produced to C. Yes, is produced to C. Then they said AC is drawn. And then with that being drawn, they said that A1 is equal to half of B. So A1 is half of this full angle. Okay, that's fine. Then it says here A2 is 46. Then they said C1 is 86. Any question where you have actual angles given, it's a very easy question. So you can always get free marks. 9.1 is a 2-mark question. They said calculate with reasons the size of A1. So the first thing we can see is that, remember, the whole angle C1 is equal to the whole angle A, because that's an exterior angle of a cyclic quad. It is equal to the opposite interior angle. So the first thing we're going to write there is that C1 is equal to A. The reason is exterior angle of cyclic quad. So we can say here A is equal to 86. So because we know that A2 is equal to 46, we can then say therefore A1 is equal to 86 minus A2, which is 86 minus 46, which is a 40. This is a question where you'll be thinking, but what's the reason for writing this out? This is a given. You see, it's part of the question. You can see that A1 and A2 make up the whole angle A. So together it's the 86 that we got up here. See, we've already proven that. So A1 is a 40. That's a 2-mark question. For 4 marks, they said prove, or hence prove that AD, hence prove that AD is equal to DC. So if those two lines are meant to be equal, it means that these two angles have to be equal. You see, this angle here has to be equal to that angle there. So since we know that this is 40, we just have to prove that this is also 40. To do that, it shouldn't be difficult at all, you see. So let me even write it out like this, right? This is 9.2. We can say here, if AD is equal to DC, then A1 is equal to C2. This is just a statement that we're putting out there to say that we're just putting it out there, you know, so that when we do prove that A1 is equal to C2, will be good. So we said if this is equal to this, then this is equal to that, because of, you can say here, because opposite angles of an isosceles triangle also have opposite angles. So me by writing out this statement, it's also even odd because it's not even necessary. We could even have put it right at the end, but to start off, right, we're just trying to say that we should just show that these are equal, this 40, this 40. So the first thing that I'm seeing that kind of stands out for me is that firstly we have a cyclic quad. This is important. This is an important piece of information we haven't used yet. And I'm thinking to myself, does question 9 have anything after this? It doesn't. These are just the only two questions that question 9 has. So let's make use of this piece of information. B, they said it is half of A1. No, they said A1 is half of B. So here we know that B is equal to 2 times A, which is equal to 2 times 40, which is equal to 80. This is something we can write down, but before we write this out, we can even state there, I meant A1. So we can state A1 is equal to half of B. This is given, so that we can say therefore B is going to be equal to 80 degrees, right? Since we know that B is equal to 80, we can automatically then get this angle. If we get this angle here, we can easily then get that one, because all these here add up to 180, you see. So we can say here C3 is equal to 180, or we don't even need to get C3. Let's just get C2 directly. No, we don't have, we cannot. Let's just, I'm busy rushing here. C3 is equal to 180 minus 80 minus 46. The reason is interior angles of a triangle. So it means that this angle here, this is going to be 100 minus 46. That's going to be 54 degrees. That's going to be angle C3. Yeah, C3 is going to be 54 degrees, right? So we know that this here is going to be 54 degrees. So it means that therefore C2 is 180 minus 54 minus 86. What is this going to give us? It's going to be 60 and 80. So that's like 40, which is what we want, you see. You see, we've proven that that is equal to 40. So we can say here, therefore, A1 is equal to C2, proven. Hey, but my pen is finishing. You see, so here we can say, therefore, AD is equal to DC. So fortunately, even since we wrote out this entire statement up here, just having to have done this and then this, it's good enough to give us our 4 marks, you see. So, yeah, pretty good. Since we're working backwards, the next question is obviously question number 8. Let's do it. Question number 8 in this paper 2, November 2024 end year exam. It says here in the diagram, right? We have this diagram here, quite interesting. In the diagram, C is the floor of a vertical building, yes, and D is the top, yes, of the same building. The height of the building is CD, yes, and then they said here CD is 16 meters, as we can see there. Then it says here 2 observers are standing 19 meters apart at point A and B. So there's one observer here, another observer over there. Then it says here A, B, and C lie on the same horizontal plane. A painter is working at point E, yes, on the building. Then it says the angle of elevation of D from A is 46.885. Then it says here angle DEB is 122. Then it says here BCA is 105.61. Very, very descriptive, and it's quite interesting that they've put a whole building there as a picture as well. So this is a 2 and a 7 mark question, right? The 2 mark question says calculate the length of AC, which is the distance between the observer and the floor of the building. So if you're going to calculate this distance, it looks a bit straightforward, but let's see if it really is straightforward. The information we can use is actually from this triangle here, right? So let me just draw that triangle first. This is 8.1, right? And looking at our sketch, the 2D triangle we can use is DCA, right? So there's DCA, there's D up there, C is down here, A is down there. This is a 90-degree angle. They told us that this is 46.85, and then they told us that this is 16. So since it's a right angle triangle where we have an angle here and a side there, it's easier to work out AC using Pythagoras. No, using the tan ratio, because this is opposite over adjacent. So we can say tan A, yo goodness, why is this writing so bad? Tan A is equal to opposite over adjacent. Opposite here is DC, adjacent is AC. So putting those values in there, it's going to be 16 over AC. Then you're going to have tan 46.85. Whew. Okay, so this is going to be over 1, right? So you're going to have to cross multiply this times 16, this times that. So you're going to have AC tan 46.85 equal to 16, because we cross multiplied. Divide both sides by the tan 46.86. This is what you're going to have. Moving on, right? From here, you can just put this in the calculator. Whew. I don't have my calculator here, but guess what? I have a phone that has a calculator on it. I literally just downloaded it. Android is the bomb sometimes. Keyword sometimes. So I have a fraction button that I put there, and then I want to put the 16, so it's like 1, 6, down there. Gonna put 10 on degrees, yes, degrees. 10 46.85. We're getting the answer there for 14.998. So this can be rounded off to 15. Very, very nice. Very, very nice. Easy mark. For a whole 7 marks though, yeah, we're obviously gonna write down a lot. It says here, calculate how far the painter is from the top of the building. So we need to calculate this distance here. Question number 7 in this 2024 November Mathematics Paper 1 exam. They said in the diagram you have the graph of 10. It's actually a basic 10 graph. Wow. For 1 mark, they said write down the asymptote of f in the interval 0 to 180. Very good. Very easy mark. X is equal to 90 because this is an asymptote. 1 is a fresh mark. I hope everyone got this answer correct. Write down the values of x in the interval negative 180 to positive 180 for which f of x is smaller or equal to 0. So the part where the graph is below 0, it's this part over here. This is the part where it's smaller or equal to 0. This part over here and well, only that part because they said up until 0. So don't include this part because it's above the 0. So this is the only section where the graph of f is below or equal to 0. So you're going to say from negative 90 to 0, where the 90 is not included, the 0 is included. So 7.2, you're going to write there x is the element of negative 90 up until 0 with square brackets. 7.3 says, given that g of x is equal to cos 2x plus 1, write down the period of g. So if you remember anything from your lessons, f is the frequency. 2 here is the frequency, right? Your frequency is a 2, and your frequency has a formula. Frequency, if you divide your period, which is, there's a formula. Period is equal to 360 divided by the frequency. You see, if it's a cos or a sine graph, you put 360 up here. If it's a tan graph, you put 180. Here we're putting 360 because this is a cos graph. So you're going to say 360 divided by the 2, which is this value that will always be on the left of x. This is 180. So the period there of g is 180 degrees. That's 4 marks so far. Then they said on the grid given in the answer book, draw the graph of g for the interval negative 180 to 180. Clearly show intercepts with the axis, also as the turning point. So the one thing you want to recognize about this graph is, this is the best way to do it, right? If you think of a standard cos graph, try to think of a standard cos graph and then make the changes. So firstly, a standard cos graph is cos x. This graph from negative 360 up until positive 360, right? You are just going to see something like this and something like this. The moment you get a 2 here, it means that the graph shrinks. It means that in a space of negative 180 up until positive 180, this is where you would see this same image. You see, this is for cos 2x. But the moment it goes plus 1, you see, y is equal to cos 2x plus 1. It means that this picture is moved 1 unit upwards, you see. So you're going to have a picture where here is 1, right, and then this is minus 1. So it's going to be going between positive 2 and 0. So it's going to go up here at 2. It's going to come down, turn over here on the x-axis, and then do that. Then it's going to do this, turn here on the x-axis, and then that. This will be at negative 180. This will be at positive 180. The first intercept here will be at positive 90. The next one will be at negative 90. You see, this will be the graph cos 2x plus 1. It will go between 2 and 0. You see, because this image, which is cos 2x, it was just moved 1 unit upwards from this very, very original image, which will still be at 1 to negative 1. But then they changed the frequency first, so it means it's now going to go from negative 180 to positive 180. And then they moved it up. It's going to look like this. This is your answer for 7.3.2. Very easy, quick, 3 marks. The next question says, use the graphs to determine the general solution of this expression. Okay, that's very interesting of them, I guess. Question number 6 in this November 2024 grade 12 paper 2 exam. The first thing that they want us to do is, given this identity, use the compound angle identity given above to derive a formula for cos x plus 1. Wow. Okay, so this looks like a proof of some sort. And yeah, let's see what we can do, right? So if we're going to given what we're given, right, let's write what we're given. Cos x minus y. They said that this is equal to cos x cos y plus sine x sine y. rule of thumb, if push comes to shove, right, you can literally then just, as an answer, you can just write this out. You can put your x there, your y there, and then just rewrite all this with x and y, and then be done with it, right? That will at least get you 1 mark. But in this particular question, what I'm going to use is the law that says the following: cos theta is equal to cos negative theta. So this whole angle here, we can look at it as theta. So what we can say is that cos negative x minus y, like that. So this is going to be equal to this. So if you multiply inside your bracket here, you're going to have cos negative x plus y. So where you see negative x here and where you see this plus y, you're just going to drop them in this formula. So you will see the x there, you're going to put minus x. Where you see the cos y there, you're going to put your y. Since here now you have a plus, what you're going to do is, what are you going to do now? Come on. Question mark, question mark, question mark, question mark, question mark, question mark, question mark. What did I do next? So I don't really remember this theorem, but it's a 2-mark question, so there has to be just a quick, simple way to just easily get your marks, you know, without really struggling with anything, you know. But I'm thinking of the whole 90 minus and all that, but yeah, again, I wouldn't bother myself with a question like this until I'm done with the whole exam. I would only come back to it when I'm done with the exam, because it's something I don't remember, but when you're done with the exam, you have time to spend to think and all that. So let me just do that. 6.1.2 says, hence or otherwise show that cos 90 minus x and then cos y plus sine negative y cos 180 plus x, the whole thing, it's over cos x. I'm actually rewriting this while I'm saying it, but one thing we can both see is that this is just the compound angles of sine and cos. We just have to be careful how we write this out. For whole 6 marks, this is going to be an easy 6 marks. So let's start from the top. As you can see, I skipped this. I'm coming back to it later. Using our cast diagram, cos 90 minus lands in this quadrant where everything is a positive. So you can just write here sine x. And then here you have cos y. Sine with a negative y, this is negative sine y. Cos 180 plus cos is a negative in this quadrant. So if you're going to put a negative cos x here, it will cause this thing to be a plus. You see, because the negative cos x times this negative sine y, this would just be a plus. Down here, we have our cos x. 360 plus, it's going to be a positive. So let's just put cos y. 360 minus, in this quadrant, sine is a negative. So let's put negative sine x and then sine y. Making use of our compound angle formulas, we can easily see that sine cos and sine cos again with the plus in the middle, it is this one, sine cos plus and then cos sine. It's the same thing. So we're going to use this one, you see. So here we're going to need to make sure that we change this to just sine x plus y. At the bottom, this is cos cos and then sine sine with a negative, you see. Cos cos, cos cos and then sine sine with a negative. So it's going to be equal to cos x plus y as well. This can be simplified to tan x plus y. That's going to give us 6 marks. That's about as far as we can go which is what they wanted us to do. You see, they wanted us to show that the left side is equal to the right hand side. So you can just say here, therefore left hand side is equal to the right hand side. 6.2. What is it asking you to do? It says, given that expression, right? Given that f of x is equal to that whole expression. Question number 5. Okay, they said here in the diagram, line OP is given, and then you have P, which is coordinate -3 and -4, and then you have this entire angle here that is equal to KOP. Fine. They then say they determine without using a calculator the value of cos A. So anytime you get questions like these, right, even though this whole angle here is labeled as A, what you need to do is you need to use A as this portion of your sketch in this particular right angle triangle. As you can see, it's a 2-mark question that we're starting off with. They're asking us for cos A. Now cos A is easily just adjacent over hypotenuse, of which in our sketch our adjacent is -3, and then our hypotenuse is this value, which we're going to work out to be a 5. So let's work this out first, right? OP squared. Using Pythagoras, we know that OP squared is equal to -3 squared plus -4 squared. This is 9 plus 16, this is 25, of which OP squared, if you put it under square root, you get OP is either plus or minus 5, but then this number cannot be a negative, so this has to be positive because your hypotenuse is a positive number. With that being said, we can then say therefore cos A is equal to adjacent, which is the -3, hypotenuse, which is the 5. So -3 over 5. There you go. Moving on. The next question is asking for cos 2a. So cos 2a, we need the following, right? Cos 2a, we already know that it's a compound angle, so it's easy if you break it down into smaller trig ratios. Let's say cos squared alpha minus sine squared alpha, because at least we know what cos alpha is. I mean cos A rather. Cos A, we worked it out to be 3 over 5, and that's just squared. Sine A, we can clearly see that sine A is just opposite over hypotenuse, so -4 over 5. So we have here -4 over 5 squared. This we can easily put into the calculator if you want. You see, this would be 9 over 25. Here, this would be 16 over 25, which will give us a negative -7 over 25. That's why these 2 marks are easy to get, because we're just using the sketch and basic trigonometry. 5.1.3 says, given this, right, sine A minus B, it is further given that sine B is equal to this, and B is between, we have to work this out. If it is further given that sine B is between 90 and 360, okay, B is between 90 and 360, so we know that the angle B is, this is 4 over 5. So ideally our angle B would also end up in this quadrant, because this is a positive number and a positive number, but then between 90 and 360, right, which is here within that region, here you have a positive and a negative, here you have a negative and a negative, here you have a negative and a positive. So for us to end up with a positive ratio, our line has to be here also, meaning in our sketch we also have to draw B here, you see, and then since this is 4 over 5. This is opposite over hypotenuse. Hypotenuse is going to be a 5. Opposite is going to be, oh, okay, I see it now. The 5 cannot be a negative, so this won't work actually. No, this won't work. Our 4 has to be a positive number, so logically, even if I think we have to put it here in this quadrant, because opposite will be a positive number. So we have to put our value, our angle B here, because opposite is here. If this is 4 and this is 5, this makes sense. And then here, when we work it out using Pythagoras, we'll get plus or minus 3 here. We'll put a minus 3 because it's to the left, because Pythagoras 5 squared is equal to 4 squared plus x squared. Here would end up with 25 minus 16. This would be 9. We end up with plus or minus 3. We take the negative 3 because it's on the left side, because opposite over hypotenuse, these are positive values. So they said we should work out sine B minus alpha. So the first thing that comes to mind is just compound angles here, you know, of which if we use our formula sheet, we can see that sine alpha minus B, or sine A minus B, gives us sine cos with a negative and then cosine. So this is going to be sine cos and then cos A sine B, like that. Sine A we already have from the previous sketch. We can just check that out. Sine A is just opposite over hypotenuse, so that's negative 4 over 5. Cos B is adjacent over hypotenuse, so that's negative 3 over 5. Cos A is adjacent over hypotenuse. So that's negative 3 over 5. Sine B is opposite over hypotenuse, which is 4 over 5. This, I would suggest just putting it in the calculator, but let's see here. We have 12 at the top over 25. Here we have negative 12 at the top over 25. A negative and a negative just gives us a plus. And then we have 24 over 25. There we go. So that's our answer. It's a 4-mark question. I'd say it's 4 marks that were freely given since it was not a difficult question. Moving on to 5.2. 5.2 is over there. 5.2 says the following. It says here, if cos alpha is equal to P, express the following in terms of P. It's also just the same kind of a question. We're just going to draw a sketch to help us, you see, because cos alpha is equal to P. Excuse me. We have to put this over 1. And the basic sketch we can always draw is this one. Adjacent over hypotenuse. Hypotenuse adjacent. This value here, we can work it out using Pythagoras theorem, you see. Then working it out, we're going to have 1 minus P squared under square root. That's a value of y. So here, 1 minus P squared under square root. This is alpha. So if you're going to get a value for this expression, this is quite interesting, because what we're seeing there is something that appears to be half angles, and in my mind I'll be thinking, wait, half angles, how did those get in the syllabus? Are they are they still in the syllabus? Well, without panicking, let's see what we can do for ourselves here. Let's see what we can do. The first thing that comes to mind is, for some reason I'm thinking of this double angle of sine. It says 2 sine alpha cos alpha, right? Now what we know is that if we, let's say what do we know here? What am I seeing? I'm seeing alpha over 2 and then another alpha over 2 over there, and then the whole thing itself is over 2. Okay. So if we had to divide this by 4 on the left and divide by 4 on the right, we're going to have 1 over 4 sine 2 alpha, and then here we would have 2 over 4 sine alpha cos alpha. Logically speaking, this would end up giving us, technically this is a half, right? So this would be sine alpha cos alpha, the whole thing over 2. This would technically be sine 2 alpha over 4, logically speaking. The reason I'm getting here is because I want to have a structure that looks like this. So here, even though the sine and the cos are swapped around, it still is somewhat this format over 2. So if I change this to alpha over 2 minus 45, we're going to have something like this: sine 2 alpha over 2 minus 45. This is sine, what else do we have here? We have technically alpha over 2 minus 45 cos alpha over 2 minus 45, and the whole thing is over 2. Okay. So since this is what we have to work out, right? Remember, this thing here, it's exactly the same as this thing here. The sine and the cos, they're just swapped around. But if you look nicely, this and this, they're exactly the same. So we can easily work with the left-hand side because it's easier to work with. So using the left-hand side, this we can multiply. Technically, remember, this 2 and this angle, you can multiply them together. I think I should have just used the placeholder, like let's say theta, so that we don't confuse each other. Let's change this to theta. So where theta is, I threw in the alpha over 2 minus 45. You see, alpha over 2 minus 45, alpha over 2 minus 45. So this we can multiply inside, because remember, this is together, the 2 and the theta there. So there you're going to have sine 2 times alpha over 2 there. That's just going to be alpha minus 90. And then the whole thing here is going to be over 4, right? And then logically here, what you can do for yourself is you can swap around the 90 and the alpha, right? Let's just put a quarter in front there. And then here, what you can actually do for yourself is you can take out a negative as a common factor. You can have negative here, you can have negative alpha, close bracket, and so forth. So from here, you need to think of this law: sine negative theta is equal to sine with the negative and then theta there. So all we're doing now is this negative, we want to write it outside, 90 minus theta, so that we can just use our cast diagram, CAST. Sine 90 minus is in this quadrant, so everything is a positive here. This we change it to cos as a positive number with alpha. And then now we can make use of this. Cos alpha is just equal to P. So when we see cos alpha there, we can just change that to a P. This is going to be negative P over 4. Very nice question. Very interesting question. It definitely required us to use some form of creativity, and we did. And I think this is exactly what they wanted us to do. So from here, we're going to move on to the next question. Remember, we're going through this paper from back to front. So the next question is question number 4. Let's do that. Question number 4, starting off with this analytical geometry question. It looks quite straightforward and basic. This will be the easiest 20 marks so far, I guess, because the sketch looks too basic to lose marks. in the diagram, M is the center, so automatically this is going to be equal to 90 degrees, because a line that is the diameter of a circle, it will always subtend a 90-degree angle. That's a law. When it says here, the circle cuts the x-axis at N, and then it says here, ST is a tangent, yes. So we already have the 10 chord theorem here. You see, this angle, this is your chord, so this is the angle that it's equal to. This angle is a 90-degree angle. You see, because there's a radius and a tangent. A radius and a tangent always meet at an angle of 90 degrees. Information that we know there. And then it says here you have P. Where is P? P is a point where the tangent meets the circle. R is a point on the circle. Then they say D is a positive number, obviously, because it's on the positive side of the x-axis. That's too general, but yes, we can see that. L lies on the circle, yes. And then it says OV, where is O? O and V are the x-intercepts of the circle. Or rather, it says here O and V are x-intercepts of PL. PL. X-intercepts of PL and RL respectively. Okay, so if you look at the straight lines PL and RL, this line PL has this x-intercept, this line RL has this x-intercept. It's clear to see that the x-intercept of this graph here is a 0, so that could be useful. 2 minutes spent reading the description. Not bad, because the rest is going to be free-flowing. They say determine the coordinates of L. It's a 2-mark question. The coordinates of L, this is over here. Now, the one thing about L is that it's a point on the other side of your diameter. There's a middle, there's the one edge. This we can get it using the midpoint formula. Because the midpoint formula, remember, it can be dismantled and used as 2 formulas. X value of the midpoint is x1 plus x2 over 2. The y value of the midpoint is going to be y1 plus y2 over 2. You see. So the information we have is that this will be the x value of the midpoint, y value of the midpoint. This we can label it as x1 and y1. So with that information, for our x value for our midpoint, we can just put the 1 is equal to 3 plus x2 over 2. For the y, we'll just put the 3 is equal to 9 plus y2 over 2. You see, multiply both sides by 2 here. You can have 2 is equal to 3 plus x2. X value is going to be negative 1. Here, multiply both sides by 2. You can have 6 is equal to 9 plus y2. This is going to be negative 3. You see, so the value of L rather, is just negative 1 and negative 3. Straightforward. 2 easy marks, even though there's a lot of writing. Excuse me. Determine the equation of the tangent ST of the circle at P. So getting the equation of this tangent, it's quite straightforward, because remember, any equation that you need to get, if it's an equation of a straight line, always start off by writing the standard form, because once you write the standard form, you can see you need the gradient and the y-intercept. To get the gradient of this tangent, you can make use of the gradient of the radius. Once you get the gradient of the radius, you can just use the formula that says that gradient 1 times gradient 2 is equal to negative 1 if they are perpendicular. So let's get the gradient of MP. The gradient of MP is going to be y2 minus y1, x2 minus x1, and then M, the coordinate of M is 1 and 3. Coordinate of P is 3 and 9. And we said we can label this x1, y1, x2, y2. This is giving us 9 minus 3, 3 minus 1. This is 6 over 2. This is 3. Yeah, that's quite steep. So if this is the gradient of MP, it means that the gradient of ST is equal to this number flipped over, and we changed the sign. All we did was we said 3 times M2 is equal to -1. Divide both sides by 3, we have -1/3, like that. So we have the gradient. To get the y-intercept, we obviously just need a coordinate that the line passes through. So we can use this formula of a straight line. Y minus y1 is equal to mx minus x1. x1 and y1 will be a coordinate that the line passes through, which is 3 coordinate 9, you see. That's the line that the graph passes through. So here we're going to have y minus 9. Gradient we have, x value is 3. So this is going to be -1/3 x plus 1. And then everything goes to the other side except for the y, -1/3 x. 1 plus 9, that's a 10. There you go. That kind of makes sense, because if the y value here is a 9, this one logically could be a 10, yes. Everything makes sense so far. So we have 6 marks so far out of in a space of 6 minutes, not too bad. And then it says here, show that the equation of the circle with center M is given, or rather is that equation, therefore 4 marks. So putting that equation in that format, you don't have to immediately get it like that. You can always just use the standard form first, and then once you have the standard form, you can just multiply out the different brackets to end up with what they want us to have there. So but let's do that. What is going on here? Where's the paper that I'm supposed to be? Here it is. So let's just do that. Let's write down the basic equation of a circle and then take it from there. The standard equation of a circle, right, we already know, and we can always get it from the formula sheet if we need it, because it's there to use. It's free. Let's actually double check the equation of your circle. This is its standard form. It's on your formula sheet as well, so that's what you start with. You're gonna write there, this is 4.3, right? So you're gonna write x minus a squared, y minus a, and then equal to r squared. And then you have the, let's put in our center, right? Our center is 1 and 3, so the x value of the center is 1, so you just drop it as it is there. And then the y value of the center is 3, so you just put here a 3 where that b is, so that will be -3 in the formula here. Your radius, it's this distance, which you can work out using the distance formula. So let's actually just quickly get our value of r there. So our r is going to be square root, we're using the distance formula, right? So to get our distance of our center, we're just going to say 1 minus 3 squared, 3 minus 9 squared. We're just using the distance formula. So this is giving us -2 squared, -6 squared. This is like 4 plus 6 times 6 is 36. Then this is square root of 40. So let's just put r there as square root of 40. So we'll have there x minus 1, x minus 1, and then y minus 3, y minus 3, and then here we said it's square root of 40, the whole thing under square root. I mean the whole thing squared, right? Because that's the value of r that we got there. Now, are we satisfied with the answer so far? Yeah, so far so good. Carrying on, we can just simplify that. X squared, and then here minus 2x, and then plus 1. Here y squared, and then minus 6y, and then plus 9. And then here we can say minus 40 when it comes to the other side, because the square root here comes with that square, the 40 goes to the other side. This now we need to make it look like the question, you see. So let's just write x squared first and then y squared afterwards. So x squared and then y squared, and then it says negative 2x there as we have here also. Then it says negative 6y as we also have, and the 9 minus 40, that's where the oopsie oh no, the 1 and the 9, that gives it 10. 10 minus 40 is minus 30. Yeah, perfect, easy, 4 marks. The next question says we should show that D is a 7. D is the one coordinate of R, and I don't think that's a 2-mark question for some odd reason. Wow, it is. I guess I overestimated the question. So if it's just a 2-mark question, you don't need to overthink it. The only question is, oh, fortunately we now have the equation of the circle, so we can just put 1 as the value of y in this equation. Yeah, I see why it's a 2-mark question now. So that's 4.4, right? So inside 4.4 we can have the x squared. Our y value is a 1, and then we can just solve for x. We should get a 7 as we have been suggested there. This is minus 6 minus 30. I just rewrote everything. What a wow. Put everything in standard form. 1 minus 5. This is minus 36 plus 1. That's minus 35. If you use the quadratic formula, this goes minus b plus minus b squared minus 4ac over 2a. I'm not going to dwell too much on this particular question because I think we cracked it already, so why waste time on something that is just too straightforward? So let's see here, over 2 times a. Here logically we're obviously going to get a value x is equal to 7, or what's the other number that we're logically speaking going to get? Well, who knows what it is, but it's not essential right now. All we need is x is equal to 7, because that's one of the values we get if you factorize this expression, if you use your quadratic formula. So moving on here, or rather before we even move on, well, we can move on now. It's really not a big deal. Yeah, unless, let me just check if I didn't make a silly mistake somewhere. I don't think I did. Put a 1 there, put a 1 there. Negative 36 plus 1, that's negative 35. Yeah, everything looks fine. We don't need the next value, we just need the 7. Moving on, what do we have here? Logically speaking, the other value would have been a negative number somewhere here, because that's the other value where the y value is a positive 1. But let's move on from 4.4 here. 4.5 says the following: calculate the size of L. So we need to get the angle L, right? Angle L is this angle here. So if you get that angle, you have L. Funny enough, the reason why I pointed out this angle is because this side of the sketch we have 90, and we have the potential of maybe getting this angle, then we get this angle that will give us L. Whichever way, getting L shouldn't be a problem because we have quite a bit of information in this sketch, and we have a right angle triangle. What I'm already thinking of doing is just basic trigonometry, you see, because this length we already have. This here is square root of 40, right? Logically this will be square root of 40 also. So the entire length here is 2 square root of 40. What I'm thinking of doing is to get the length of LR, sorry, so that I'll say adjacent over hypotenuse and then get this angle. Let's just do that. LR, right, using the distance formula, we're just gonna say x2 minus x1 squared, y2 minus y1 squared, and then what are we gonna get here? We're going to get our 2x values, right? So we're going to say here, what do we have? Technically it's going to be -1 and -1 minus 7. Yeah, -1 minus 7 squared, and then here it will be -3 minus 1 squared. Here we're going to have -8 squared, right? -8 squared, and then -4 squared. This is 64 plus 16. This is 70 under square root. So the distance here is square root of 70. So with that being given, right now we have a sketch that looks like this. You see, it's a right angle triangle. This is square root of 70. This is 2 square root of 40, and we need this angle. This is adjacent over hypotenuse. So we can say cos L is adjacent over hypotenuse. And then we can say L is equal to shift cos with our square root of 70 over 240, 2 square root of 40 there. This, well, obviously need a calculator for that. And somebody here misplaced their calculator, so, but I have this very, very, very convincing calculator like app here. I need to clear everything though. Shift clear. No, my guy, clear everything. Well, what's going on? Shift clear equal to no. What a wow. This calculator is failing me, and yet we're like so close to getting this angle, because everything we need is already here. Let me just see here. Okay, so we're getting there, 48.59 degrees. That's fine, not too bad. Moving on to the last question out of 3. It's 4.6 there. It says TR is a tangent to the circuit R. Where is TR? TR. Okay, so it's a new line that they're talking about. TR is a tangent to the circuit R. Prove that PT is perpendicular to RT. Okay, so that doesn't seem like a difficult thing to do, because this is the line they're talking about. They said it's a tangent as well. They say we should prove that that line is perpendicular to our other tangent, and it's a 3-mark question. Remember, if lines are perpendicular to each other, obviously it means they meet at an angle of 90 degrees. But funny enough, this line and this line have to be parallel for this to be a 90-degree angle. So all we can do is, well, technically proving the gradient of this line here is not gonna be too easy, because firstly, we only have one coordinate, but we have this point here, point R. Logically speaking, if we can prove that MR is parallel to PT, that will be also good enough. because if MR is parallel to PT, it means that our line here is perpendicular to PT over there. I don't think that what we said here is too, excuse me, I don't think it's too overly complicated. Let's actually just execute without wasting any time. So let's just say construct MR, right? Construct MR. So once we construct MR, right, logically speaking, MR is a line that is perpendicular to our tangent TR. So here we can say MR is perpendicular to TR. The reason for that is just tangent perpendicular radius. You see, you can write here tangent perpendicular radius. For 3 marks, I don't want to oversimplify the answer. I don't want to write something that is too basic and too simple, but at the same time, it is what it is, you know. But to make things maybe a bit more believable, even if maybe we didn't write this out, let's just prove that the gradient of MR is the same as the gradient of PT. So let's write here gradient of PT. We have proven it in the previous question. We got it to be, remember that was also the gradient of ST. We got it to be negative a third over 3. This is negative a third over 3. This has been proven. So since we have that knowledge, right, let's just get the gradient of MR. The gradient of MR is going to be y2 minus y1, x2 minus x1. And here we can just use 3 minus 1, and then we can just use 1 minus 7, and then you're going to have 2 at the top. Down here you're going to have negative 6. This is just negative a third as well. You see, so we can say therefore the gradient of, therefore we can say MR is parallel to PT. So we've proven that those two lines are parallel to each other. We've proven that those two lines are parallel to each other, and we have proven here that MR is perpendicular to TR. So with that being said, we can say that therefore PT is perpendicular to RT, which is also TR, right? Because they are corresponding angles. You see, so all we did was we proved that this line here is parallel to this line, and then we proved that this angle is a 90-degree angle. So if this is a 90-degree angle, this has to be a 90-degree angle as well, because they are corresponding angles. Remember, you have parallel lines and one line passing through both those lines. It means you have corresponding angles. So for 3 marks, this is not too overly complicated. So let's move on to the next question. Question number 3 says, in the diagram below, A, C, D are vertices. Yeah, we can see that. And then they said, yeah, or rather the triangle ABC has vertices A, D is given, C is given. And then it says here where A is the point in the second quadrant, yes, B is a random point on the line DC. So since we're working backwards, clearly these questions, they seem to have been getting a bit easier. But anyways, here we are. They said calculate the gradient of DC. That's as basic a question as it gets, you know, because we have a gradient formula already. So just put the stuff in the gradient formula. This is 3.1. Our gradient formula, we know it's y2 minus y1, x2 minus x1. This will give us the gradient of DC. So, simply put, we can just say negative 9 minus 0, negative 9 minus 0, and then 3 minus negative 3. That's going to be plus. No, 3 minus 9, my guy. So this is going to be negative 9 at the top, and then this is going to be 12 at the bottom. If you put that in simpler terms, 3 can go into both of these, so negative 3 over 4. That's straightforward. Nothing really to worry about here. So let's just keep moving forward. 2 marks extra. They're asking us to determine the equation of DC. It's an equation of a straight line, as we have already been told, as we can also see. I said already, anytime you need to get the equation of a straight line, just get the gradient and the y-intercept. Gradient we already have. So you can just say y minus y1, m, x minus x1. Our m, we got it to be negative 3 over 4. x1 and x and y1, this is just a coordinate that the line passes through, so you can put d or c, it's up to you. So I would rather put, it doesn't matter actually. Here we can put as x, this we can put as y. So you're gonna have y, if you put a negative 9 there, it's gonna be a plus. And then, oh oops, here if you put an x, that's just x, and then here you have to put a y value, x value, which is a 3. Simplifying this, you're ending up with negative 3 over 4x plus 9 over 4. This is y plus 9. Everything on one side, you have negative 3 over 4x. This minus the 9, you are going to have, should have just had a calculator, because it's really not necessary to be doing all that. Let's just put this in the calculator. So 9 over 4 minus 9 over 1. So this is giving us negative 27 over 4, which is 6 point something. So negative 27 over 4 makes better sense, which is fine, because that's like negative 6 point something. So negative 6 point something, it is a number that is clearly before the negative 9, so that makes sense. The next one is saying show that k is equal to negative 6. Where is k? Show that k is equal to negative 6. That's fine. If this is negative 6, that makes sense, because remember, this is like negative 6.75 according to the calculator. So this is a free mark, hence why it's just a 1 mark question, because you have the equation of the line anyway. So here in 3.3, right, you're just going to put the y is equal to negative 3 over 4x minus 27 over 4. The y value that you have there is a k. The x value is a negative 1. So if our equation is correct, we should get a 6 here. And we are getting a 6. a negative 6 rather, because this is just 0.75. 0.75 minus 6.75, that's gonna give you a negative 6. Okay. Yeah, moving on. The next question says calculate the length of CD. Wow, these guys were just giving away marks, yeah, for this question 3, because it's too basic. But oh well, we're not going to refuse free marks. Square root symbol. The one value of x is negative 9 minus 3. This is just a basic distance formula that we're using here. This is negative 12 squared. This is 9 squared. This is giving you 144, 81. 144 plus 81. Well, let's see what that gives us. 144 plus 81, 225. So we want square root of 225. Let's see. Square root of 225 is going to be 15. So the length there is 15. Very, very easy. 19 marks I'm seeing here. But anyway, so far we've gotten 2, 4, 5, 6, 7 marks. Not bad. Those are very simple questions anyways. The next question is saying calculate the ratio of dB over dC. So if you have the length of DC already, you're fine. If we get the length of BD or dB, we can just throw that there, then we have a ratio. Because we have 15 here, dB, we can also just use the distance formula because we have D here, B there, both coordinates are given. So yo, very easy marks. This is 3.5, right? So dB, again, distance formula, you're just gonna say -1 minus 3 squared, and then you're gonna have -6 minus 9 squared. Okay, so from here I made a mistake because this is actually supposed to be a plus. Okay, so from there means that would have had the BD or dB is equal to square root of -4 squared, -6 plus 9, that's going to be a +3, and then that will be squared. So here you're going to end up with like 16 plus 9, which is technically 25, of which the square root of 25 is just plus or minus 5, but we're going to take a +5 in this case because distance cannot be a negative value. Okay, so from this question, right, the next one says if M is a point on AD such that AC, with AC is this line here, AC is parallel to MB, calculate the ratio of the area of MBD and ACD. Okay, so this is a straightforward question because the ratio of the sides of similar triangles will always be corresponding to the ratio of the areas, you see. So what you know, all right, as a law, the ratio of the area of any two sides, the ratio of the areas of two triangles that are similar will always be equal to the ratio of the sides squared, any two corresponding sides. So what we already know is we know dB and we know dC. So the ratio of dB and dC, oh no, we didn't finish this question. dB over dC, right? dB over dC, this is going to be 5/15, okay, which is technically a third. So if you're going to work out the area, the ratio of this area, right, for 4 marks, all you're going to have to do is the following. We just have to show that those two triangles are similar first. So triangle MBD, so there's MBD there, right, and triangle ACD. Let's just prove that they're similar first. So 3.6, we're gonna say in triangle MBD and triangle ACD. Firstly, no, it's not A, it's D. D is a common angle, so that's the first thing we're going to state there. D is equal to D, that's a common angle. And then, since these lines are parallel, it means that MBD is equal to angle C. MBD is equal to angle C because they're corresponding angles, because they told us that MB is parallel to AC. So because those two pairs of sides are equal, we can even then say A is equal to BMD, also because they're corresponding angles. A is equal to BMD, also corresponding angles, right? And then if you want, you can put the MD parallel to AC. So here we can then say, therefore, triangle MBD is similar to triangle ACD. So because we've proven that they're similar, we can then say, therefore, the ratio of this one area here, right, over the area of this triangle here, right, the ratio here is going to be a third squared, which is just 1/9, you see, because the law says that if any two triangles are similar to each other, it means that the ratio of the areas of two similar triangles will always be equal to the square of the ratio of any pair of their corresponding sides, you see. So what that means is, we know that the ratio between BD and DC is just 1/3. So if you square that value, it will give you the ratio of your areas. That's simply put. Let's move on to the next question, which is the 3.7 over there, right? 3.7 says, it is further given that the gradient of AD, where is AD? AD is here. They said it is further given that the gradient of AD, right? Okay, question number 2, here we are. So remember, we're working backwards, and as of this recording, clearly I've skipped quite a few questions already. Not a lot, but maybe like 4, which I'll go back to as I always recommend, right? So I'm just trying to put my words where my mouth is. What? Put my money where my mouth is. Oh yeah. Anyways, question 2 says, calculate the cumulative. It says the cumulative graph, right, shows the time taken in minutes for 60 employees to travel to work each morning. So this is a cumulative graph, right? So this cumulative graph already shows us that from 0 to 20 minutes, it was a total of 5 people. Then when you added the next 20 minutes, people that took more than 20 minutes to 40 minutes, you'd accumulated to a total of about 13 employees going on until you reach 60 employees. So this clearly shows that the time that some of the employees, the longest time that some of the employees take to get to work is about 120 minutes. That's almost 2 hours. Wow, that's a lot. Anyways, they said here, determine the median travel time. The median travel time, what you do is, you need to get where half of the cumulative frequency is. It's at 30, you see. So you're gonna trace that 30 to your ogive, which is somewhere there, and then you're gonna trace it down to your time. So this is between 60 and 80. So for 2.1, simply put, the median time travel is where your time is bigger than 60 but smaller or equal to 80. That's your median time. That's a 1-mark question. They said estimate the lower quartile. So if you're going to estimate the lower quartile is Q1, you see. So the position of Q1 will always be 1/4 n plus 1. So in this situation, this is going to be like 60 plus 1. A quarter of like approximately 61, or 60 rather, is about 15, you see. So you're going to go to where 15 is. You go to your ogive, and then you trace it downwards. This is clearly between 40 and 60. So 2.2, our lower quartile, right, is between 40 and 60. Okay, fine. The interquartile range. Remember, the interquartile range will always be equal to Q3 minus Q1 divided by 2. So Q1 and Q2. So logically speaking, how would we go about answering this question? Let's see. Q3, right? Let's see, Q3. You would have half of 30, and between 30 and the 60, you're gonna be at 45. So if you trace that to your ogive, it's gonna be here somewhere. You see, this is giving you between 80 and 100. That's where your Q3 is, right? But then if you're then gonna get the interquartile range using a cumulative frequency graph, this is what you do. But before we carry on though, here for 2.1 and for 2.2, we had to get the estimate between 60 and 80 and the estimate between 40 and 60, because look at the question, estimate the median travel time. We know the median is between 60 and 80, the lower quarter is between 40 and 60. So the median itself, right, logically speaking, if you look nicely, between 60 and 80, that's a jump of about 20. In the middle is about 70, you see. So this is like 68, 66 minutes. That's our estimate. And then for our lower quartile, our estimate here is 44 minutes. Okay, 44 minutes. The reason for doing this is, if you're going to get our interquartile range, right, we need the estimate for our upper quartile, which is 84, you see. So Q3 is equal to 84. Therefore, our interquartile range is going to be 84 minus 44 divided by 2. This is going to be 40 over 2, which is 20. There you go. The interquartile range is 20. Moving on, 2.4 says the minimum and maximum times taken for an employee to travel to work are 5 and 20 minutes respectively. On the scaled line in your answer book, draw a box and whisker diagram to indicate the distribution of the data is represented in the ogive above for 2 marks. So if you're going to draw a box and whisker diagram, right, fun enough, if we use this as more of like a scale, right, your minimum, they said here the minimum time is 5 and 20 respectively. So 5 would be like somewhere here, right, somewhere here. 120 is like exactly somewhere here. So that's the minimum and the maximum. Q3, we said it's somewhere here. Q2 is somewhere here. Q1 is somewhere there. So you would join these with the box, right, and then you would just join this here with the line there and the line there. Perfect. This is exactly how you would do it. You would need to make use of your box and whisker. You can make use of your cumulative frequency graph to help you draw your box and whisker diagram. That's why this is literally just a 2-mark question. You see, you can label it. You can have the max. Min. What am I doing? The minimum is where you start. The max is where you end off. Q1, Q2, Q3. You see, and then that should be that. You can even label it if you want. You can put here 120. You can put there 84, 66, 44, and then 5. Without wasting time, the company for 5.2 says, 2.5, the company manager decided that all employees who travel for an hour or more will be allowed to work from home for part of the day. Okay, what percentage of employees will be allowed to work from home for part of the day? So ones that travel for an hour or more. So let's see, the 1 hour starts here. So ones that travel an hour or more, right, you take where you see 60 minutes, you trace it to your ogive, and then you trace it to the employees, right? So from here you're gonna trace this. This is like on the first thing there, so that's like 26. So 26 employees are the ones that take less than an hour, you see. So you're going to say 60 minus 26. So for 2.5, right, let's say 60 minus our 26 here. Let's see what we get. 20 minus 26. This is giving us, technically, my math is not mathing. This is like 34. Is it? Nope, it's 44. Wait, what? Dude, how am I doing such a silly mistake? No, it is 34, because if you take 6 and you put it there, that's like 40 plus 20. Yeah, so you have 34 employees, right? Travel. No, it's not 34 employees. Yes, it is, because it's a total of 60. Travel more than 60 means, so we need a percentage of that, because they said here what percentage of the employees will be allowed to work. So it's going to be 34 out of 60 times 100. This is going to be 34 100 over 6, which is like 340 over 6. This we obviously are going to need to get an answer from the calculator. This is just too obvious. So the percentage of people here, according to the calculator, let's clear this. 340 divided by 6, that's like 57%, because here the answer is actually 56.66%, which is approximately equal to 57%. Okay, very good, easy marks here. So out of the 10 marks, we have 2 more to get. Employees work 8 hours in a normal work day. The manager decided on the following rule. So in this grade 12 November 2024 exam paper 2, we finally made it to question 1, because remember we're working backwards. So when I'm done with this particular question, I'm going to browse through the paper from the back, see what questions we had recommended that it's better to leave and only come back to later, and then I'll just calculate how many of those marks I actually left out, and then obviously from there I'll then just go to the questions, work them out, and then we can move on. So question number 1 says, at the beginning of a season, the coach of a juniors rugby team recorded the weight in kilograms of 15 players in his team and the number of push-ups that each player was able to do in 1 minute. Okay, the data is presented. The data is represented in the table and scatter plot below. The least squares regression line of the table is drawn. Okay, so you have your data, the number of weight here and the number of push-ups that people can do. So based on the least squares regression line, it looks as though as the weight of the individuals increased, the number of push-ups that they were able to do decreased. That's what the data is somewhat looking like. It says determine the equation of the least squares regression line of the data. So in practice, 20. Yeah, so that's your data in your calculator, right? Okay, so yeah, for my regression I had to press shift and then start, then I go to regression in this calculator. So we need a value of a, right? No, the value of a was 39 point something, so that's 1.1. Our value of a here is currently 39.46 rounded off. Our value of b, we can do the same thing, shift stat regression, get b there, that's like negative 0.59. So our equation is definitely then going to be y is equal to 39.46 plus no, it's a minus 39.46 minus 0.59x. you see, in that equation we can also see it on our formula sheet, because the equation of our least squares regression line, as you can see on the formula sheet over here, a plus bx. Okay, not too bad. Those will be how many marks? 3. So as you can see, if you don't have a calculator, these types of questions they get annoying, but it's just basic calculator work to get the answers here. So let's move on to the rest of the question. They said here, point 2 actually, 1.2 says write down the correlation coefficient. So the correlation coefficient, shift stat, correlation coefficient is our value of r. This is negative 0.7. Well, if you round it off, that's like 0.8. Okay, well, let's write it without rounding off first, and then put the approximated value here. You see, like that. So the reason for doing this is it's easier to write out the number before rounding off and then the number after rounding off, you see. So 1.3 says the coach uses the least squares regression line to set the target for the minimum number of push-ups by each team member according to their weight. Predict the number of push-ups that a member of the team who weighs 29 kilograms should do to meet the target. So 29 kilograms, that's a value of x. So in the equation, right, where you see x, you're gonna put 29 over there, and then let's see what this gives us in the calculator. So in the calculator, we can have there 39.46 times not times, man, it's minus 0.59 times the 29 there. That should be 22.35, which is approximately 22 push-ups. That's rounded off, you see. So then they say it here, right? Write down the mean number of push-ups for the given data. So the mean number of push-ups is the mean of x. So shift stat, let's see here, we have our data, the mean of x variables. There you go. So the mean of the x variables, whoa, let me do this because I see this thing is going to be giving us funny things. There we go. The mean is 35.8, which is approximately equal to 36 push-ups. Okay, and then it says here, the players trained hard during the season. At the end of the season, the coach reported that each player was able to do 5 more push-ups per minute than they did at the beginning of each of the season. How does the increase in the number of push-ups influence the standard deviation of the data? So since everyone increased by 5, the standard deviation stays the same. Standard deviation stays the same, you see, because all the numbers moved upwards by the same degree. Then it says here, at the beginning of the season, the coach used, well, reading the question again also, it definitely does fall under the types of questions that I said. It's best you move on, come back to them later. So as of this recording, what I'm going to do is I'm going to put together all the questions I went through. I'm going to circle the ones that I left out, tally the marks, see how much I would have gotten so far if I had just, example, did what I have always recommended, which is to go through the exam. If you bump into a question that seems just too crazy and too off, move on, come back to it later, and then the time that you would have banked, you can use that to go through all those questions. So let me actually start from here and round up all the questions that I would have left out and come back to. So starting with these 2 marks here. So on question 1, I left out these 2 marks, so that's 2 marks. Let's put that there. Question 2, I think I left out these 2 marks here. That's another 2. So let me just do this. Q1, Q2, Q3. Let's see if I left out anything. Q3, Yes, I left out these 6 marks here so far. You see, I still have to come back to them, but I left this one out. That's 6 marks. I think everything else I went through. Question 4, did I leave out anything? Nope. This I did everything here. I'm pretty confident about what I wrote down. So question 4, there's nothing. Question 5, did I leave out anything here? Nope. Question 5, I left out nothing. Question 6, did I leave out anything? Yes, I remember leaving out something here. I left out this question so far, this question, that's like 4 marks so far, and then plus 6, that's about 10. Wow, that's a lot of marks, but I'm still gonna come back to them, remember. Question 7, I just want to give you an idea of what I normally recommend you do with these exams. You see, this question, 4 marks. I think I haven't finished this one, so 4 marks here. Question 7. Question 8, let's see, question 7, yeah, it was this 4 marks here. The rest I remember doing. Yeah. Question 8, did I leave out anything? Yes, I definitely did. This 7 mark question, I was like, you know what, let's move on and only come back to it later. So wow, question 8, I left out that 7 mark question, which I am gonna come back to obviously, but I just want to give you an idea of how this method works. Everything here I did. So question 9, didn't leave out anything. And then question 10, did I leave out anything in question 10? I don't think I did. Calculate the length of PT, I remember doing that. Ratio, I remember doing that. This, I remember doing that. So question 10, nothing was left out. Question 11, this I left out. Yes, that's another 6 marks here. Question 11. Okay, so those are the questions I've left out so far before I finish. You see, I'm gonna come back to them obviously, but let's just see how many marks those are and how many minutes actually. See, so this is like 10 plus 10, that's 20, plus this, that's another 10, so that's 30 minutes plus 7. So I've left out 37 marks. So in essence, I left out 37 out of 150. So all these questions that I left out, I think it's a better idea if I just put them in one separate video, because it automatically shows that these are the types of questions that were a bit difficult. So I'll put those in a separate video. I'll put the link to that in the description. If you don't see it right now, I'll edit once the recording is done. But I think it's best I just compile the short clips that I've made for this paper so far, put them together, upload the video, and then I can just come back to these and then go through them, because so far we're sitting on 75%. Not too shabby, but we can definitely do better. So let's do that.